everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we're taking a break from our usual programming for a special conversation around the core areas CloudOps teams should be monitoring and other CloudOps best practices. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over on Spotify, Apple Podcasts, or wherever you like to listen. I started by asking Mike to give us an overview of the key areas CloudOps teams should be monitoring and what they should be focusing on.
When we think about cloud monitoring, what we're thinking about is this big holistic system. So we're not just thinking about the cloud itself. So a lot of organizations have actually sort of moved to this digital first, this cloud first strategy. So where we've actually put applications and services and relying on the cloud to deliver that. And they've actually done this because they're actually looking to gain a benefit. So this may be improved performance, easier to control, and sort of spin things up, sort of this horizontal scalability in areas like that. But when we actually do this, what we need to consider is we're actually now thinking about this complete mesh of environments. So we have these cloud environments all over the place where we have distributed architectures, we have distributed users, and then distributed networks connecting together. So we've got to think about a number of things. If we think about sort of the main areas of what we're going to be doing, we're going to think about this cloud migration approach. And this isn't a one-stop thing. We're not just lifting and shifting and putting stuff out there. The architecture of the applications and the environments are going to change. So we're going to make use of different services around there. So we have to take that in consideration. We have sort of the applications. Are we going to use hybrid applications? Are we going to use a SaaS application? Is there part of that system, such as a database, which we're actually going to control? This is all this continuous improvement journey where you need to go along because you have many moving parts in there. So you have to have this ongoing operational excellence. It's no good anything sort of going down or starting to slow down. We've also then got to think about the sort of the actual costs of actually running this cloud infrastructure.
Tell us more about those performance health indicators CloudOps teams should pay attention to, and why those data points should be looked at holistically rather than in isolation.
Again, we're talking about this complete mesh of environments, and we've moved on from this day where we have client, network, server. So, or even if you think about this sort of tiered architecture, we have the front end. There's all these different dependencies, and I like to think of a network no longer as this linear process, but essentially of this mesh of environment. Now, also on top of this, driving sort of our business requirements has been this necessity to essentially increase the complexity because we want to reduce latency. We need to have our applications as close to the users as we can possibly be so that, we can't improve on the speed of light, so we can actually move parts of applications. So then it's actually understanding which part of those applications or which part of those services need to be close to those users. But because we have all these different moving parts essentially involved in there, we have to be able to look at this holistically. But we've also now got infrastructure. We've got infrastructure we don't own in that environment. So how are we actually going to marry that in? If there's an issue on there, how's it going to impact these users? So we've got these multiple different potential vantage points around our area. So we have the infrastructure, we have our end users, we have the networks, we have the transit providers, we have the cloud providers, we have the tier 2 cloud providers. Everything needs to come together to deliver this service to us. So we have to be able to look holistically and take in all those data points. So if we're then thinking about all these data points, we're talking potentially of hundreds of thousands if I'm looking to correlate that. The problem if I actually take some of those in isolation or I look at one part of that, I can misdiagnose what's going on. I can make a planning decision. I can move something over where it doesn't need to be moved over, or I can migrate something to the cloud, doesn't need to be migrated to the cloud because I'm making sort of a partially informed decision. So I need to be able to see everything across that entire service delivery chain to understand what's going on and what I need to interact with. On top of that, you also need to consider this from a performance perspective. So what are we going to do going forward? By understanding everything across that whole area, not only can I diagnose these issues, but what I can also do is understand these areas for optimization. So it may be that we've got one particular single point of failure, as it were, or single aggregating point, even to the point where my cloud providers are connecting together. I might be splitting across 2 cloud providers, but they're using a same route to get to that point. So I need to understand these areas of convergence, these areas of commonality. And because I need to do this holistically, what I can then start to do is to make these decisions based on my requirements relevant to my performance. And what I mean by that is we can start to make decisions on if I actually put this workload in this particular cloud provider because my user population is there, it's going to cost me X number of dollars. Now, if I simply put this over the other side of the world or in this different provider, I might get a sort of a lower cost, but it's at the cost of, let's say, 20 milliseconds in terms of performance of that particular part of that transaction. So then I have all that information to make a decision. Is the cost involved in me actually deploying that workload at that particular place worth the costs I'm going to get in terms of performance? So I'm really starting to combine that business perspective with the performance to make sure I meet the requirements. Now, if you think about the cloud providers, they all have solutions and tools on board there which allow you to understand the usage and those types of patterns. But it's looking at it in isolation. It's looking at how you're using that resource. And that's fair enough because that's the world they're looking at. But you as a user or as an enterprise or someone who's actually doing this cloud migration have a responsibility to do that end-to-end service delivery chain. So you're going to go across all these areas there. You'll have a responsibility if you don't have accountability for all those parts. And by looking at everything together is where you can really start to make those informed decisions.
How do you ensure you're focusing in on the data points that matter most, the performance of those end-to-end user journeys?
So again, let's come back to this aspect where we're talking about this complex mesh around there. We have sort of various points in there. So we need to understand what's happening from a network perspective. So which path am I taking where I'm going through? Because this is how I'm going to understand where those commonalities are coming through. So understand those. If possible, let's get that from a hop by hop perspective to understand what's occurring there. Also then, because I'm dealing with the performance aspect, I want to see that performance in relation to usage. So I want to try and understand what's happening from the cloud providers themselves. So let's actually look at that from a usage. So things like sort of the VPC traffic. So that's my traffic flowing between those two areas there. But then let's come into the actual cloud infrastructure itself. What I'm really interested in is once I've got there, and we've talked about this a lot in some of the outage analysis, when we can get to the front door of a service, but then it's some sort of issue within the back-end system. So then we're starting to look at sort of what's happening from those back-end systems from an infrastructure perspective. I'm not saying I need to instrument those devices themselves or that infrastructure itself, but what I need to understand is there something gone on with that environment? So be that configuration change. Is there something, a workload's gone unhealthy or been taken offline that my traffic is going to? Basically, what I'm looking for is to take this usage data and do attribution to it. So where is my performance degradation or where's my load actually sort of coming into there? So this allows me to do a couple of things. This allows me, as I said, to understand what's happening from a performance perspective, but also understands me to do attribution to see where is the bottleneck or where is a particular configuration change or system that's impacting my overall service delivery chain. Now, once I actually put all those together, if you think about the cloud providers themselves, and even if you're looking at from your ISP scenario, you'll also have individual SLAs. So the service level agreement is going to tell me what's going on there. Now, I'm not saying you specifically need to measure each individual SLA, but what you'll want to do is what you're really concerned with is if a system's up and running, that's great, but it's not great if it is impacting your performance overall. So what you need to understand is that holistic service, that service delivery chain, and be able to set, if you like, some sort of benchmark, or let's call it a service level objective. What do we need to achieve to be able to deliver this service to our business requirements and our users' expectations? And that can only be done if I'm looking at holistically across the whole environment. And what you do is then you're going to take those sort of data points or those signals from each one of those. Now, if I look at those individually, it might be everything's sort of green and that's all good. Or even if everything's green and one's yellow, that might not necessarily be a problem. But if we have two of those in sort of a state where it's yellow, it might be improved, it might be delayed performance, there's a flow-on effect where it actually starts to impact that. So by combining this, the usage, the infrastructure metrics, the performance metrics from a distributed environment across where my users are coming from, how my availability zones or how my cloud providers are connecting together, the paths I'm taking and putting it all together, what I then get is that when all these signals are at this particular level, then this is normal for our environment and this is what we want to achieve. And I can start to move on from there. And also what it allows you then to do is attribution. If this particular signal drops or rises, it causes this problem. We start to understand that pattern and then we can make changes to the workaround or understand the fault domain where we actually need to do mitigation or process we need to take into place. But also it allows me to optimize that. We talked about the commonality between some of the paths coming through from some of these areas there. What if I actually then go, I'm actually going to have a workload here and here because I know I've got two diverse paths, and back to that sort of performance. So it allows me to do informed capacity planning as well as this more real requirement for the troubleshooting and understanding what's happening in that environment there.
With so much complexity to manage, are there ways teams should be looking to streamline their service delivery chain?
We say that this environment is complex out of necessity, and this is because of today's requirements. So the business requirements, the user requirements have sort of seamless interactions. But the CloudOps teams, although they have a very specific area of responsibility, if we think about that service delivery chain, they also have some sort of responsibility for that end-to-end service delivery chain, to assuring that service delivery chain. So to be able to do that, what they actually need to be able to see is to take in information that is outside of their realm of responsibility, but is pertinent to the problems they're trying to solve, which is to be able to deliver these services to their end users or make sure they're happening. So they don't necessarily need to then to become experts within the network. They don't need to understand what's happening, for example, at a BGP level, where there's been a BGP hijack taking place, or there's some sort of downstream providers had some network issue there. All they need to understand is there's a network component that's actually impacting their ability to serve their users. Now, if I put all that together, what they need to be able to see is that information in context. That's not just simply a case of there's a problem, it's on the network, but they need to be understand how that is impacting the ability for that service to be delivered. So they understand then from an attribution perspective where it can go, be that they escalate that to their ISP or to an internal department. Or it may even be is when this error occurs within your environment and it comes here, this is the playbook you run, which may start some other automated process up. So in the case of, say, BGP route hijack, it may advertise their network out a different prefix. So therefore then sort of changing the path. But they also, this visibility in the context of what they actually need to see is also, again, for this optimization perspective we're talking about. By understanding where they are, they can see where these commonalities are occurring. So then they can start to sort of work around these bottlenecks, or when they're doing a design to go to the next stage, how do we optimize there? Where is our single point of failure? Where is an area where we're starting to have a slowdown occurring? That could be on a particular function. They might be calling a different function from a different cloud provider. It may be when they're making a change to environment. That then also becomes important because they're making a change essentially in isolation. So they're making a change, for example, to a security group, to a firewall service within their cloud provider, within their workloads that they're actually looking at there. They make that change essentially in isolation. They'll need to see how's that impacted their whole service delivery and to see if the change they've made has had a negative or positive impact. Now, this becomes important because they are constantly making changes, or we need to constantly make change. We're tweaking things there. But I need to be able to see that in the context of that overall service delivery because it might have unintended consequences. So the sooner I can identify there's that particular issue taking place, I'm then in the position to say, okay, we can roll this back, or we can continue pushing it on because this is not the problem there, or we can just stop it and put a fix in. But without that visibility, one, they're blind to it, and then they're always coming back in and saying, well, was it that change we've made? And if it's gone too far in the process, they can't roll it back, which then can sort of extend that delivery time overall. So it's really about sort of taking in all these disparate points and being able to view them within the context of their persona and relate that to the use case and the problems they're trying to solve.
What information do CloudOps teams sometimes miss, and what impact can that have on decision making and planning?
This actually looks sort of more fundamental. So it's understanding sort of how these providers are connected together, understanding where their workloads need to be placed. And again, because they're sort of doing this, not blind, but they're doing it in an isolated fashion. So we're saying, okay, this is the deal that provider A is going to give us. It's going to cost us this much for our compute resources. We can have this service running on there, and that's where we're going to go. It's not essentially then viewed in that overall, what's the service we're trying to deliver? But if I can understand what the service is, how my components are broken up, all the different parts together, then I can actually come back and make a decision. Do I go a hybrid environment? Sort of do I have something local? Do I split between a tier 1 and a tier 2 cloud provider? I have my database locally stored. There's all these types of considerations. But if I'm only making a decision based on a capacity and not an overall service performance, then I'm going to have sort of gaps in that portfolio. And this is then why I need to be able to put everything back together so I can make that informed decision. And that's not to say that cloud provider A is going to perform better for cloud provider B. It's how do they perform relevant to what it is I'm trying to achieve? Where's my user population? What availability zones are in this area here? What's the diverse routing taking place? Where, if I'm going here, my user base here, what paths they actually go through? So it's more of joining the dots together to complete the picture so we can color it in, so we can see what's occurring overall.
How often do you think those decisions are made on a pure cost basis rather than what's better for the whole environment?
I think they're made a lot of the time on terms of a cost basis, and they're sort of made regularly. Quite often they're made, this is what it costs us this year. We need to reduce costs. We're going on here. And those decisions are often made in isolation, or they're made within silos. We're looking at the performance of that part of the service delivery chain. So how quick can we process? Can we offload that particular service instead of looking from a whole? And it might even be that what we can do, it may be that you could take a performance hit of 5-10 milliseconds on that particular part of my application, because in the overall scheme of things, I'm actually still going to meet my business requirements. My users aren't going to notice, but I can actually sort of reduce those costs. Now, there isn't necessarily sort of quite hard to do that correlation from cost to performance, but at least what it does, it gives you that actual information so you can make decision. Now, if we had it in this location, if we had a workload here, even to the point of, let's consider this, even had the point is we're not going to have sort of all these diverse areas there, we're just going to go in one. At least I know the impact. This is where my service delivery chain goes. These are my potential bottlenecks. And then our mitigation plan, our workaround plan, if we happen to have an issue in that particular area, is this. We can afford to do that. The actual cost of having this complete system around there is more than the risk we'd actually take for sort of having a downtime of 30 minutes. Now, that's obviously not an ideal situation. And that's an extreme situation, but you can actually at least start to make decisions, and you can actually put that performance relation in terms then of a cost. I'm now starting to put these disparate data sets together and actually sort of bring them into a level where I can actually make a decision.
And finally, Mike, what about AI? As companies embrace generative AI in particular, how will this impact what CloudOps teams need to monitor?
There are many things that have to be considered in this area. Sort of in particular, let's talk about which models we're going to use, where we're going to go, and think about the data that's going into that particular model. We start to now run into this area of data sovereignty and data residency. So there's going to be a need specifically to understand where is my data going to be located, where I'm actually going to go there. And if you think about the contextual glue that holds all this together, it is a network. And if I've actually have this large distributed environment where I'm actually sort of running different models, different areas in a fairly aggressive Gen AI plan there, how many apps will actually need to interact with this? And I need to understand sort of where they're located, how that network is connecting together, and the speed of which I can actually get between these 2 points. Does it make it viable to do that? Or do I need to look to have something in a local data center close to where everything's sort of close together, which then you start sort of build up risks in there. Essentially, what we're talking about here adds another level of complexity. We're dealing with a completely different architecture again. We're dealing with not just from the infrastructure, but we're dealing with a different application architecture that has different requirements, be that from a network connectivity, but also that from the idea of sort of a sovereignty residency perspective. So we need to sort of match those two together again with what we were talking about before in terms of how does that match my business requirements, as well as in some cases, some of my regulatory requirements.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.